Improved coordination between suppliers and manufacturers. The implementation of connected supply chain solutions has helped some manufacturers reduce supplier reject rates from 30% to less than 2% in just 4 months. These systems create what's known as a supply chain cloud, ensuring all stakeholders make decisions based on the same real-time data. Through cross-company transport optimization and shared capacity systems, modern factories are achieving new levels of efficiency in their supply chain operations. The integration of advanced shipping notifications and real-time tracking has significantly improved inbound processes and supplier service levels. AI-powered manufacturing solutions. Artificial intelligence has emerged as a cornerstone of modern manufacturing, with AI-powered solutions delivering measurable improvements across production processes. These advanced systems are transforming how factories operate, making them more efficient and responsive to change. Machine learning applications. Machine learning algorithms are reshaping manufacturing operations through sophisticated data analysis and pattern recognition. These systems analyze visual data with remarkable accuracy, identifying even subtle defects while efficiently handling large production volumes. Manufacturing companies implementing ML-based solutions have reported significant improvements, with defect detection rates increasing by 60% compared to human inspections. Key benefits of machine learning in manufacturing include automated visual inspection systems, real-time process optimization, enhanced product quality prediction, improved production scheduling, automated inventory management, predictive analytics and maintenance. Predictive analytics has become a crucial tool for maintaining equipment efficiency and preventing costly breakdowns. Companies utilizing predictive maintenance systems have reported a 70% reduction in equipment breakdowns and 25% lower maintenance costs. These systems employ sophisticated sensors and algorithms to monitor machinery health, enabling maintenance teams to address issues before they cause production delays. The implementation of predictive maintenance has shown remarkable results, with manufacturers reporting equipment downtime reduction to just 52 minutes per maintenance cycle. This proactive approach helps optimize maintenance schedules and extend equipment lifespan while ensuring continuous production flow. Quality control automation. AI-powered quality control systems represent a significant advancement in manufacturing precision. These systems employ advanced machine learning algorithms, particularly deep learning neural networks, to offer unmatched speed and precision in defect detection. Visual inspection systems equipped with AI can detect various defects, from surface imperfections to complex anomalies, with greater accuracy than conventional methods. The integration of AI with augmented reality technologies has further enhanced inspection capabilities. AI-powered AR devices such as smart glasses and headsets provide frontline workers with real-time feedback and ensure compliance with standard operating procedures. This combination of technologies has enabled manufacturers to achieve quality control scores of 93.1 points, marking a 0.76% improvement in overall quality metrics. Through the implementation of AutoML tools, even small and medium-sized enterprises have seen notable improvements, with some reporting a 3.19% increase in productivity and a 2.15% reduction in defect rates. These improvements demonstrate how AI-powered solutions are making advanced manufacturing capabilities more accessible to businesses of all sizes. Human-machine collaboration. The integration of advanced technologies in manufacturing has sparked a new era of human-machine collaboration, where workers and automated systems complement each other's strengths. This partnership is reshaping traditional roles while creating opportunities for enhanced productivity and safety. Workforce transformation. The manufacturing landscape is witnessing a fundamental shift in job roles and responsibilities. Studies show that automation is taking over routine tasks, allowing workers to focus on more complex, technical activities. This shift has led to the emergence of new positions, such as digital twin engineers and smart factory managers, requiring a blend of traditional manufacturing knowledge and digital expertise. Skills development for Industry 4.0. The rapid advancement of manufacturing technology has created an urgent need for workforce development. Current manufacturing skills become outdated within 3 years, highlighting the importance of continuous learning. Essential skills for Industry 4.0 include data analysis and interpretation, digital system operation, problem solving and critical thinking, cross-functional collaboration, technical maintenance and oversight. Training programs have evolved to meet these needs, with organizations implementing innovative approaches such as AR, VR-based training simulations, real-time digital learning platforms, hands-on cobot collaboration exercises. Safety and productivity enhancement. The collaboration between humans and machines has yielded significant improvements in workplace safety and efficiency. A recent study demonstrated that human AI systems achieved 100% accuracy in safety monitoring tasks, while traditional methods reached 99%. The implementation of collaborative technologies has shown remarkable results. AI systems independently identified 67.3% of safety protocol errors. Training time reduced through AI-generated guides and real-time assistance maintenance procedures optimized through predictive analytics. The success of human-machine collaboration depends heavily on proper training and support systems. Organizations that prioritize employee development have seen improved talent retention and workplace satisfaction. Through strategic upskilling initiatives, manufacturers are creating environments where humans and machines work together effectively, leading to enhanced decision-making capabilities and improved operational efficiency. The integration of collaborative robots, or cobots, has been particularly successful in areas requiring both precision and human oversight. These systems excel at repetitive tasks while allowing human workers to focus on more complex, value-added activities. This symbiotic relationship between workers and technology has become a cornerstone of modern manufacturing operations. Future-proofing manufacturing. The rapid pace of technological advancement demands manufacturing facilities to adapt and evolve continuously. Recent studies show that successful manufacturers are focusing on faster, more sustainable change, with 103 manufacturing sites worldwide achieving lighthouse status through Industry 4.0 implementation.